And the specific way that we'll talk about for measuring similarity is called the vector space model. And in the vector space model, basically what you do is you try to represent everything as a vector in some high-dimensional space. And by everything, this means that our documents are going to be vectors. Individual words are actually going to be vectors, and they're usually taken to be the coordinate vectors of that space. The queries that the user puts into the system, they're going to be vectors as well. And anything else that you can think of, you represent a vector as a vector in the same in the same space. So if you have, for example, user preferences, or if you have a user browsing history, or anything else you could think of that could be relevant to the ranking, you would try to embed it in the same vector space. So when you have a vector space, there are some basic things that we need to, some basic questions that we need to answer. So in a vector space, we need to figure out what the dimensions are going to be, and so what the basis vectors or coordinate vectors are, and that's an interesting question. There's lots of ways to approach this for text. Once we've determined what the dimensions are, how do we project everything to that vector space? How do we project the documents and the queries into the vector space? And then finally, once everything is represented as a point in that vector space, how do we measure distances? How do we measure a similarity of a query in a document if they're both points in that space? Right, so dimensions, that's a really critical issue, and while there are many different alternatives to try, there is basically a dominant way to do it, and a dominant way to do it is to use individual words as dimensions of the vector space. So you're going to have, for every word in the vocabulary, you're going to have a different coordinate vector. So all the words are in effect going to be sort of orthogonal to each other. Now, if you remember anything about linear algebra, that should raise some red flags immediately, right? Because one of the assumptions when you're forming a basis, when you're forming a set of dimensions for your vector space, the basic assumption is that they are orthogonal. The basis is supposed to be orthogonal. So your x, y, and z in your vector space, they're supposed to point perpendicularly to each other. In statistical sense, this means that they're supposed to be independent. They're not supposed to be correlated. They're not supposed to either positively or negatively. And that's something that words don't obey, right? Words will have strong positive and negative correlations. So a word like Barack and a word like Obama, they're not independent. They have a much higher chance of occurring together than separately from each other. So that is immediately a problem. You have lots of other problems as well, right? If we use individual words, the dimensionality of our space is going to be humongous. So we saw Heaps' law in the last lecture. You're talking about millions and hundreds of millions of dimensions in your space. Well, what's even worse is if you're dealing with a constantly arriving data, your dimensionality is going to keep growing and growing and growing. So if you're a search engine, as your crawlers gather web pages from the web, you constantly get new text. And by Heaps' law, you're going to constantly see new words enter the vocabulary. So the dimensionality of your space is going to be growing and growing and growing. And what does that mean in a linear algebra sense? Well, that's madness. You don't even want to go there. If theoretically, it's not a well-defined thing. So could we use something else? There's been lots of attempts to try to do something a little bit more theoretically palatable. Right? So instead of individual words, you could imagine, so let's take some core semantic concepts, some ideas that are not going to change every time we crawl another 10 gigs of text, where new concepts aren't going to be added. And then we could possibly try to represent everything in terms of those concepts. So those are nice ideas. Unfortunately, none of them work out in practice. So in practice, what you use is single words, right? Despite all of their disadvantages. Right?